All right, let's jump right in. Today, we're unpacking a really fascinating real-world bug bounty scenario. If you're looking to level up your hunting game, or just kind of want to see how a tiny misconfiguration can snowball into a massive data leak, you're in the exact right spot. Think of this explainer as a hands-on, over-the-shoulder mentoring session. We're going to step into the shoes of a security researcher, fire up Burp Suite, and methodically tear apart a target web app to uncover a hidden information disclosure vulnerability. It's basically a digital puzzle, and we've got to find all the pieces.
So, here's our game plan for this one. We'll start with a quick refresher on info disclosure and bug bounty, then jump right into Recon and content discovery. After that, we're inspecting some JavaScript for hidden endpoints, hunting down missing HTTP headers, exploiting the leak we find, and finally, amplifying that entire risk using IDOR. Let's get to it.
Section 1. Info disclosure in bug bounty.
Now, the exploit we're looking at today isn't some magic one-click zero-day. It actually requires chaining a bunch of smaller discoveries together, which honestly is exactly how real-world bug hunting actually works. At its core, an information disclosure vulnerability is just a flaw where a web app unintentionally spills sensitive data to unauthorized users. Our target for this explainer is a bug bounty service called firstblood version 1, and what we're going to see is a pretty complex leakage scenario. The data isn't just sitting there out in the open, it's hiding behind a very specific sequence of requirements.
Moving on to Section 2. Reconnaissance and content discovery.
Any good security researcher knows you always start by scanning the landscape, right? You're looking for digital leftovers, backup files, unlinked pages, the works. And Burp Suite makes this workflow incredibly smooth. First, you analyze your target domain. Then, you pop open the engagement tools and you run Discover Content. Basically, this spiders the website, aggressively trying to brute force its way into finding linked and unlinked pages. It takes a little time to run, sure, but it is an absolute goldmine for finding stuff developers either thought was hidden or just flat out forgot to delete.
After letting that tool do its thing, we take out the results in the Burp target tree. Right away, a file named hackerback.html catches our eye. But when we actually navigate to it, the page response looks like a total dead end. It's just a generic landing page saying, "Event is at full capacity. Please check back later." On the surface, nothing spectacular. A regular user would just close the tab and walk away. But we're not going to do that. We need to look a little closer. Which brings us to Section 3, inspecting JavaScript for endpoints.
Let's peek behind the curtain. When we view the page source for that seemingly locked hackerback.html page, we skim past all the boring HTML formatting and boom, we spot this script. It's a JavaScript function firing off a fetch request to a completely hidden API endpoint called attendees_event.php. And check out that query string. It's asking for a specific event ID. The developer probably left this API call in the code to dynamically load attendee data, maybe before the event actually filled up. Oops. Naturally, we copy that endpoint, toss it into the browser, and then throw it into Burp Repeater to see what happens. We hit send, and we get a 200 OK response code. The server sees us, but there's a catch. There is literally no data. It's just a completely blank response. We try removing characters, tweaking the URL, still absolutely nothing. So the big question, do we just give up here? Call it a dead end? As researchers, absolutely not. We have to dig deeper.
All right, Section 4, finding missing HTTP headers. We are definitely missing a key to unlock this API. To find it, we pivot back to the Target tab in Burp to see what else that content discovery tool dug up for us. Looking at the identified files, we can safely ignore stuff like Doctor Panel or Logout for now, but look at the bottom of the list. There's a highly suspicious file just called Site Settings. Now that sounds exactly like the kind of place where global configuration parameters or API rules would be stashed, right?
So we send that site settings file straight over to Burp Repeater and analyze the response. And wow, here is our massive breakthrough. The settings explicitly outline an event handler process, and it states that it requires a custom HTTP header to function. The header is X-Site-Req, and the required value is permitted. This right here, this is the literal key to the door we've been banging on.
Section 5, exploiting the information leak.
Okay, fun part. Let's build the actual exploit. We jump back to that Burp Repeater tab where we were poking at the attendees_event.php endpoint. Remember when we sent the request without the header, we got a 200 OK, but a totally empty response. Well, now we manually inject our shiny new custom header. X-Site-Request permitted. We hit send, and boom. Instantly, that blank page is replaced with a massive payload of full event data. We just unlocked the vault.
And just look at the highly sensitive information spilling out here. We've got the event title, the full description, the exact time, the entire attendees list, and get this, even the canceled attendees list. I mean, people who thought their data was wiped when they canceled are now completely exposed. This absolutely confirms a severe information disclosure vulnerability. And it wasn't obvious at all at first sight because it required us to find that obscure custom header to bypass the basic control.
Finally, Section 6, Amplifying Risk with iDual. As a bug hunter, when you find a leak, your next job is to see exactly how far the water spreads. Look really closely at the API structure we just compromised. The crucial detail here is that the API query string is using sequential numeric event IDs. ID equals 1, ID equals 2, ID equals 3, and so on.
This one little detail perfectly illustrates the wider danger here. Because those event IDs are totally predictable, an attacker doesn't have to guess. They can just automate the whole thing. Firing up a tool like Burp Intruder, they can just brute force through thousands of sequential numbers in minutes. That means this vulnerability isn't just leaking data for this single hack-or-back event. It lets an attacker scrape highly sensitive data for all previous, current, and even future events across the entire web application. This is a textbook IDOR, Insecure Direct Object Reference, where manipulating an input directly exposes private records. It literally turns one tricky leak into an absolute massive data breach.
We've just seen firsthand how chaining, content discovery, JavaScript inspection, and header manipulation can crack an application wide open. For developers out there, let this be a huge wake-up call to implement strong server-side access controls and actually validate user permissions. Security through obscurity, like hiding behind a weird custom header, is honestly no security at all. So I'll leave you with this thought. How many other web applications out there right now are hiding sequential IDs behind a single, easily discoverable missing header? Keep that in the back of your mind the next time you fire up your tools. Thanks for joining me on this explainer, and happy hunting.